Soldering copper pipes. Make sure you have the right equipment. The first thing to do is make sure that you have lead-free solder if you are going to use it on drinking water pipes, hot or cold water pipes that are used for drinking or bathing. So first of all, cut your pipes to size. Make sure you've reamed out the burr on the inside formed by the cutter when you cut the pipes. This will cause damage to the pipes if left in, and noise. Can even cause leaks after a certain period of time. Then we have to clean the fittings. To do this, screw up the steel wool as tight as possible. Push it tightly into the fitting using your thumb against your finger. Push the steel wool against the other edge of the fitting with your thumb, squeezing the steel wool against the inside edge of the fitting, and then clean the inside thoroughly. The cleaner you get the fittings, the more chance you have of not having a leak. Okay, these manufacturers that make these modern fluxes say you do not need to clean the pipe and fittings. I would strongly advise you to always clean your pipe and fittings, for the simple reason you don't know what chemicals or what type of dirt are on there, and this could cause the flux to fail. So if you always clean your pipes and fittings thoroughly, you will have the minimum chance of having a leak. So after cleaning the fittings, clean the ends of the pipes, and then we come to fluxing it. Now, I never use a brush because brushes can be contaminated. I always use the solder to put the flux on. Always only put the flux on the bit that's the area that's going into the fitting, and always use the minimum amount, but make sure every piece of the pipe is covered in flux. We never use flux on the fitting, only on the pipe. Clean off any flux that's happened to get on the inside of the pipe, because we only want the flux on the pipe, not in the fittings. As we push the pipe into the fitting, we twist it gently so that the flux will then go into the fitting and on the surface inside of the fitting, avoiding getting any flux inside the fitting. We do not want flux inside the fitting, because if we are using this on airlines or gas pipes, then that flux, that acid flux, will eat through from the inside of the pipe to the outside of the pipe and eventually cause a leak. So as you can see in that photo, there's no flux on the inside of the pipe. It's very important that you do this right from the beginning if you're going to be a gas engineer or do any sort of pipe work in industry where you're not using water to flush out the inside of the pipe to get rid of the flux. Okay, so when we're ready to solder, before we start soldering, we wipe off the excess flux from the edge of the pipe, because we don't want it all running down our pipe work and dripping onto the fabric of the building we're putting the pipes into, because it's very acidic and can cause problems. We only want it on the inside surfaces of the soldering, where we're going to solder on the capillary surfaces. So to light our blow lamp, make sure it's not too fierce. It shouldn't be loud enough that you can hold a conversation with a quiet voice next to the person who's standing next to you. And the hottest part is the inside blue cone. You can't really see it on the video, but in the real world you will see this. There's an inner cone and an outer cone. The inner cone is a slightly darker blue. Okay, when we're soldering, always hold the solder, if possible, opposite the flame, because we don't want the flame to melt the solder before it goes onto the fitting. So heat the fitting evenly on both sides first of all to get it warm. Try to avoid heating the pipe too much, because we don't want the pipe hot, we want the fitting hot. Copper is a good conductor of heat, so it will conduct heat through to the pipe. Okay, these are capillary fittings, so they work on capillary action. So we put the solder in one place, usually opposite the flame, therefore avoiding melting the solder with our blow lamp before it goes onto the fitting. So we keep touching it opposite till it melts, then we move the blow lamp away and put enough solder in so that we can see it on the side of the pipe where the flame is. So it's gone all around the fitting by capillary attraction. Same with the other fittings. So we've done all three, and as you can see, only entering the solder at one point and watching that the solder runs around the fitting by itself. Never be tempted to move the solder around the edge of the fitting, because all you'll be doing is putting molten solder on the edge of the fitting, and the solder won't be going into the fitting itself. When it's upside down, if you put too much solder in, it will then run down the pipe. The art of soldering is to put enough solder in without it running down the pipe. Any excess solder that's still molten, wipe it off immediately with a dry, clean rag. Once the work's cooled down for at least 30 seconds to avoid thermic shock, if you cool it off straight away, the solder and the copper expand and contract at different rates, so you could get what's called a thermic shock, and the solder will shrink back from the copper, causing a later link. Clean off any excess flux with a wet, damp rag once it's cooled down enough, and then finally clean off the fitting, any heat coloration marks off the fitting with a bit of steel wool, so it's ready for the customer to do any necessary painting or for any inspection of your work, and it stops the copper going green and being attacked by the acid at a later date. Okay, so there's no solder running down the pipes, and the solder is going all around the pipes, as you can see, and inside the pipe there is no solder and no flux.